Okay, so we're going to work on some review problems, some basic math skills that we should know. So first off, we are going to simplify using arithmetic and the order of operations. So we're going to just use some basic math skills here. So the first one we're going to look at is 6 plus negative 2 in parentheses. And what did that equal? So this is equal to the same thing as 6 minus 2. That plus and minus still means minus. And 6 minus 2 is equal to 4. So if we look at another one, we have 3 plus a negative 7 is equal to, now this would be the same thing as 3 minus 7, just so you understand. Now, one of the things I want you to point out here, on this first one, our bigger number was positive. These have the different signs. This one's positive, this one's negative. So you're going to subtract when they are opposite signs. You will subtract and keep the sign of the bigger number. So 6 minus 2 is equal to positive 4. Here we have a positive and a negative, and so they're still opposite signs. So opposite signs mean we will subtract and keep the sign of the bigger number. So this is still a subtraction problem, so 7 minus 3 is equal to 4, but because the 7 is a bigger number, it is negative 4. If we look at 4 plus negative 9, we don't have to rewrite them like this. I just want you to see it's the same thing. So 4 plus a negative 9, because they are different signs, we will subtract and keep the sign of the bigger number. So 9 minus 4 is equal to 5. 9 is the bigger number, and it has a negative sign, so it's negative 5. Now, if we have examples like this, so let's say this is example 1, this will be example 2. If we have numbers that have the same sign, so negative 6 minus 2, they are the same sign. They're both negative. When they're both negative, you're going to add them. So 6 plus 2 is 8, and keep the sign of the negative. If you think about it, if you have something like 6 plus 2, well, those are the same sign. They're both positive. 6 plus 2 is 8, and we always kept the sign that was positive. So 6 plus 2 is equal to 8. They're both positive, so it's positive 8. This is negative 6 minus 2, so that's two negatives. They are the same sign. You add them and keep the sign. So hopefully that helps kind of clarify what you're doing. When they're opposite signs, you will subtract, keep the sign of the bigger number. When they're the same sign, you will add and keep the sign. So let's look at another one. If we look at negative 3 minus 7, 3 plus 7 is 10. Keep the sign is negative 10 because they are the same sign. Same thing will happen with negative 4 minus 9. Well, they're the same signs. We're going to add them, and 9 plus 4 is 13. They're both negative. We keep the sign of, and we end up with negative 13. All right, let's go look at example 3. So here we're following order of operations, and we're going to use some of the skills that we have previously used. So we're going to take care of order of operations. Remember, we've learned that as PEMDAS. They've kind of changed a little bit, but instead of just parentheses, we're looking at groupings. Groupings can be parentheses, brackets. There's several types of ways to look at them. So here we have parentheses. So we're going to take care of what's inside the parentheses first. When we're doing that, we do not look at anything outside of those parentheses. We just look at the parentheses themselves. So we'll bring down the 11 minus 6 minus 3. Well, they're opposite signs. We're subtracting here and keeping the sign of the 6. So 6 minus 3 is 3, and it will be positive 3 because of the 6 being the bigger number. But we have a negative sign that's following down from the original problem. Here we have 4 minus 9. 4 minus 9, that's opposite signs, we're going to subtract. 9 minus 4 is 5, and we're going to keep the sign of the bigger number. So that means it's going to be a minus 5. Now, you can write this one of two ways. You can write this as keeping that plus sign and then bringing down that negative 5, which I don't normally do, but you can if that's what makes sense to you. What I normally will do is not do that one, but I'll just bring it down as 11 minus 3. I know that's going to be negative 5, so I can just rewrite that as negative 5. Instead of a plus negative 5, to me this looks a little simpler to follow. So 11 minus 3, so understand these mean the same thing. This is exactly the same thing as that. 11 minus 3 would be 8. And then bring down your negative 5, and 8 minus 5 will get you 3. You can do the same thing over here. 11 minus 3 would be 8. Now you can still keep it as plus minus 5, or now just rewrite it as negative 5. You still get 3 as your answer. So to me it's simpler if you don't look at that sign and just bring the sign down. Here we had to keep the sign because this one's negative, and this was a positive 3 coming out. Just don't apply that until you've done the parentheses. All right, let's look at another one. So if we look at 13 minus 7 minus 3 plus 2 minus 5. So 13 minus 7 minus 3 is positive 4, so just write the 4. And then 2 minus 5, well, those are opposite signs. We're subtracting, keeping the sign of the bigger. So 5 minus 2 would be 3, but it will be negative 3. So I'm going to write that as a negative 3. 13 minus 4 is 9. Minus 3 will get us 6. All right, so the next thing we're going to look at is some decimal. So this would be example 4. So we have negative 12 minus 3.4. Well, when we're doing decimals, a lot of times it's easier if we stack them. So we have a negative 12.0, because there's no decimal place. We know it's 0.0. And then minus 3.4. So here, what we need to notice is they are the same sign, so what are we going to do to them? Are we adding or are we subtracting? Because they are the same sign, we will add them and keep the sign. So 0 plus 4 will get us 4, bring down our decimal. 2 plus 3 is 5, and then 1. And keep the sign, so negative 15.4. All right, let's look at another one of these. So we have negative 13.2 minus 5.6. So again, I'm going to stack them because to me it is easier to stack and add. So 2 plus 6 is 8. Bring down my decimal. 5 plus 3 is 8. And bring down the 1. Keep the sign. So negative 18.8. All right, let's look at example 5. So we have negative 2 over 13 plus negative 7 over 13. Well, these are fractions. The main thing we have to know about fractions is you can add them if they have the same denominator. If they don't, we will have to get a common denominator. Luckily, these have the same denominator, so we know it's going to be 13 on the bottom. You do not add the denominator, you just bring it on over. Now on the top, they are both negative. So if they have the same sign, we add them. So, and keep the sign. So 2 plus 7 will be 9, keep the sign. So negative 9/13. All right, let's look at another one of these. So negative 4/7 plus negative 2/7. Again, they are the same sign, so we're going to add and keep the sign. The denominator stays the same. Negative 4 plus negative 2, same sign, so 4 plus 2 is 6, and then keep the sign. So negative 6/7. All right, let's look at another type of problem. Example 6. We are looking at 2/3 minus 1/4. So these do not have the same denominator, and they are not the same sign. One is positive, one is negative. So we'll end up subtracting the tops, but first we have to get a common denominator. One of the easiest ways to do that is just to multiply what your denominator is. So 3 times 4 is 12. So we're just going to go with that. So that means we're going to have something over 12 minus something over 12. Now what we have to figure out is what did we multiply 3 by to get to 12? Well, I multiplied the 3 by 4 to get to 12. So whatever I do to the bottom of the fraction, I have to do to the top. Or whatever we do to the denominator, we have to do to the numerator. Either way you want to look at it. So 4 times 2 will get me 8. Now for 4 getting to 12, I multiplied by 3. So whatever I do to the bottom, I have to do to the top. So 4 times 3 got me 12. 1 times 3 will get me 3. Now I'm back to what I just did on the previous problems. I'm going to keep the 12. Here we're not adding, we are subtracting because I have a positive and a negative. 8 minus 3 is 5. All right, let's look at another example. So if we have 3/5 minus 5/6, again, we have to find a common denominator. So if I take 5 times 6, I'm going to get 30. So I'm going to have two fractions with the denominator of 30. I did 5 times 6 to get to 30. So 3 times 6 will get me 18. 6 times 5 got me 30. So 5 times 5 will get me 25. Okay, so whatever you're doing to the bottom, you have to do to the top. And notice these numbers are not the same. They're the same for each fraction, but not the same for both fractions. All right, so now I have 18 positive and negative 25, which is negative. So they are the same or opposite signs, so we are going to subtract. So 25 minus 18 will get me 7. And I have to keep the sign of the bigger number, which will be negative. And notice that denominator stays the same. So 18 minus 25 is negative 7/30. All right, let's look at example 7. So for example 7, we are looking at 14 divided by 2 times 3. Well, here we have to follow the order of operations. This is where some do not understand the order of operations correctly. It is not multiplication and then division. It is multiplication and division from left to right. So we will do exactly what it says from left to right because this is just division and multiplication. So 14 divided by 2 is 7 times 3. We do not go 2 times 3 is 6, and then try and divide 14 divided by 6. So 7 times 3 is 21. And that's all you're going to do for that problem. So multiplication and division at the same time across a problem from left to right. Not multiplication first, not division first. Same thing happens with addition and subtraction. It's addition and subtraction from left to right, which you saw earlier when we did these problems. We took care of our grouping, and then we did the addition and subtraction from left to right. Okay, so it's the same process. It's not one and then the other. You do it all at the same time. So let's look at another one like this. So if we have 24 divided by 6 times 5, 24 divided by 6 will be 4 times 5 will get us 20. Now, what if you don't know your multiplications very well? You need to try and learn those multiplication tables the best that you can. But if I don't know that 24 divided by 6 is going to get me 4, what I can do is I can go off to the side and I can start adding 6s. So I can go 6 plus 6 gets me 12 plus 6 will get me 18 plus 6 will get me 24. So now I know I have 1, 2, 3, 4. So you can go and add them off to the side to figure it out because you need to know how to do these. And not always will you have a calculator handy. But I would suggest that you make either buy some flashcards or make some on index cards and learn your multiplication tables. They are important. They make the math easier when you know those answers. If you're in my course and you're taking the competency exam, you're not allowed to use a calculator on all of these problems. You have to do them by hand. So make sure you know how to figure those parts out. All right, so now let's look at example 8. Helps if you can see. So we have 3 plus 2 squared times 4. So again, we're following PEMDAS here. That dot is multiplication. So we have to take care of the parentheses. So 3 plus 2 is 5 squared times 4. After parentheses or groupings, we do exponents. So now I have to take 5 squared. So that's 5 times 5, which is 25. And then times 4. And again, if you don't know this, I mean, this one's 5, so it makes it a little bit easier. You can go on your fingers 5, 10, 15, 20, 25. So I can count my 5s as I'm going along. And 5s are easier to multiply. 25 times 4, you can think of that as 4 quarters, which gets you 100. And then let's do another one similar to it. So if we have 5 plus 1 squared times 2. Well, 5 plus 1 will get us 6 squared times 2. So again, this is another one. If you don't know that 6 squared is 36, what I can do is come over here, and I know I'm needing to multiply 6 times 6. So you can come over here and add them. So if we're trying to do 6 times 6, that means I can add 6 sixes. So I can go 6 plus 6 is 12, plus 6 is 18, plus 6 will get me 24, plus 6 will get me 30. So we have 1, 2, 3, 4, 5 so far. So I need to add one more. Gets me 36. So you can do it that way if you need to. There's no harm in that at all. Now 36 times 2, well, that is 36 plus 36. So if you don't know what that is, again, you can come over here and you can go 36 plus 36. 6 plus 6 would be 2. Carry your 1, 3, 6, 7, 72. So if you don't know your multiplication, you can use addition in that process. I needed to multiply it by 2, so that means I'm adding 2 of them. I needed to multiply 6 squared is 6 times 6, so I have to add 6 sixes. So do what you need to do in order to understand the math there. All right, so let's look at the next type of example. So this will be example 9. So we have 5 over 8 times 3 over 4. So we have 2 fractions this time, but it is multiplication. It is not addition. You do not need a common denominator. You're just going to multiply across the top and then multiply the bottom. You don't crisscross, you just go across. So 5 times 3 is 15, and 8 times 4 is 32. Now, if these will reduce, you will reduce them. This one doesn't, but if it does, you will need to do that. We'll discuss reducing here in just a second. So we have 2 over 7 times 4 over 9. Again, straight across on the top. 2 times 4 is 8. 7 times 9 will be 63. And again, if you don't know your multiplication tables, go and add them up. And again, if it has reducing ability, you need to do so. All right, let's look at another example. So this will be example 10. If we have 1 over 4 times 1 over 3 times 1 over 2. So again, we're multiplying the top. 1 times 1 times 1 is just 1. On the bottom, 4 times 3 is 12. 12 times 2 is 24. If we have 3/5 times 1/4 times 3/4, on the top we have 3 times 1 is 3, times 3 will get us 9, and on the bottom we have 5 times 4 is 20, times 4 is 80. So you just have 3 fractions instead of 2, and you're just multiplying across. Parentheses next to each other is the same thing as a dot or an X. I try not to use X's when we're doing multiplication because sometimes when I'm teaching different courses, X is a variable. So I try not to use X as multiplication in math because then it makes it a little less confusing. All right, let's look at our last couple of examples here. So for example 11, not 10, we are looking at reducing. So reducing, we are going to look at reducing 10 over 25. What we need to do is figure out what the top and the bottom both divide by. This one's a little bit easier because we can see it ends in a 5 and a 0, so we know they're both multiples of 5. So if we divide the top and the bottom both by 5, so you can do this one of two ways. You can write this and you can show the divide by 5 on both. So 10 divided by 5 is 2, and 25 divided by 5 would be 5, or you can just show me that it reduces down to 2/5. Either way. Now on the next one, we're still reducing. Sorry about my D got a little messed up there. 12 over 34. Now, off the top of your head, you might not know what they both divide by, but if they're both even, you can divide by 2. I end in a 2 here and I end in a 4 here, so I know they're both even numbers. I can divide by 2. So if I divide by 2, 12 divided by 2 would get me 6 on the top, and 34 divided by 2 is 17. And then sometimes you might have to divide against. These are reducing down by one number, but sometimes they're going to divide by another number. So let's do another example here. So let's reduce. So let's go with our 12 divided by, let's go with 36 and see where that takes us. Well, I know they're both even, so I can divide by 2 again. So 12 divided by 2 again is still 6. And 36 divided by 2 would be 18. Well, they're both still even, so I know I have to keep on going. So I'm going to divide by 2 again. So 6 divided by 2 will be 3. 18 divided by 2 will be 9. Now, they're not both even, so I know they won't divide by 2, but I can see that they both divide by 3. So if I divide by 3 for both parts, 3 divided by 3 would be 1, and 9 divided by 3 will be 3. So it would reduce down to 1/3. So sometimes you're going to have to do a couple of steps and not just one.